Welcome to the MSJC Internet Authoring Videocast.
Welcome to CSIS 113B, Lecture 5, an Introduction to Iteration. Here's what we'll cover in this lecture. We're going to take a look at various repetition structures, and we'll talk about loops versus decisions. We were talking about decisions in the last couple of lectures, and just want to make sure you understand the difference between the two. Then we'll get into various loop constructs, loop classifications, loop categories, and we'll talk about the importance of defining the bounds and the goals in your looping structures. Then we look in detail at the for loop, its syntax, how it works, and we'll have some examples for you. So first of all, when it comes to loops and decisions, as I say, you'll hear looping referred to as repetition or iteration. All it means is we're just going to repeat some block of code, maybe a single statement, maybe multiple statements, but we want to continue to repeat that block of code until we reach our goal, as you'll learn about later on. In a way, loops and decisions are similar because they both use a Boolean condition, a Boolean expression for evaluating, in the case of the loops, when to terminate the loop. In the case of decisions, which direction we want to go based on the results of our condition being evaluated, true or false. So just remember that decisions branch code to one path or another. Repetition will repeat a block of code while the test condition is true. So beginning students sometimes confuse the two. Just want to make sure we have that clarified for you. So here's an example of a decision, which again we covered in the last two lectures. We're comparing the values of x and y here. See if x is greater than y. And if x is greater than y, then we're going to print x is greater than y. If it's not greater than y, then we're going to print x is not greater than y. So we have a true path and we have a false path. Whereas in repetition, as we said before, we want to repeat basically a block of code. In this case, while x is less than y. So as long as x is less than y, then we're going to print the value of x. And when x becomes greater than y, then we'll just exit the loop. So if you look carefully at the graphic there, you can see after the start, we have our Boolean condition where we're checking x to see if it's less than y. So we've already declared and initialized both of those variables. So as long as x is less than y, which would be true, then we continue the loop, which is we print x, we'll increment x in this case. So two statements there, printing x and then incrementing x. And then going back to the conditional statement again, testing to see if x is still less than y. If so, again, we'll print x and then increment x. Back to the conditional statement, checking to see if x is still less than y. On and on until x becomes equal to or greater than y. At that point, the condition will resolve to false. And once it becomes false, we exit the loop, process the next statement after the end of the block for the looping statements. There are three loop constructs in Java. Each one of these loops can be used interchangeably, but each was designed specifically to solve certain types of problems more efficiently. So we have a for loop, used when we want to repeat actions a specific number of times. A while loop, used for indefinite or indeterminate loops. And then a do while loop, which is like the while loop, but it differs where the test conditions occur. In the two examples we're looking at here, you can see where we have, in the first example at the top, before the actual statements that we want to repeat in the loop. And on the right-hand example, you can see the test is at the bottom. Loops fall into two types of classifications. We have counted loops, used when we want to know how many times that we want something to repeat. So that generally we're reading the lines from a file or counting the number of characters that appear in a string, just as a couple of examples. And then also another classification would be indefinite loops, which we use when we can't determine how many iterations that the loop will need to execute before performing the task at hand. Good example here, generating random numbers until a prime number is produced, or counting characters in a string until the period is located. There are three categories of the indefinite loops. Data loops, where we keep reading until there is no more data left to process. This type of loop might be employed when reading the contents of a file or a web page. Sentinel loops, they keep iterating until a specific value or a piece of data is found. And limit loops keep iterating until the answer is close enough. These loops are best employed in scientific applications and graphing. It's very important that you write your loop correctly. Loops are a common source of error in coding. Best to have a strategy to write loops correctly the first time. A professor by the name of Doug Cooper at UC Berkeley wrote a book, Oh Pascal, and in that book he outlines a loop strategy. Just to summarize for you, loops consist of preconditions, postconditions, bounds, and a goal. The most important things to know are the bounds and the goal. We'll look at loop bounds here first. The bounds is what we use to make our loop stop. Infinite loops are one of the most common errors in programming, and learning the bounds first is most important. Say you want to count the characters in a string until a period is encountered. First of all, every string will need to contain at least one period. But what are the bounds? It's the period that will be encountered. So we need steps to move towards a bounds. And what is needed to set up the loop is the preconditions. So what is needed to set up this loop? What are the preconditions of our loop? Well, basically, we'll set up a condition that tests to see, as we go through each character in the string, whether it is a period or not. Once we reach that period, then we'll terminate the loop. The loop goal, in the case of our previous example, would be to count the characters in the string until a period is encountered. Every string must contain at least one period now again, so we might want to test for that separately. So then our program should count the number of characters before we actually encounter a period. So what do we need to get to that goal? Would we need any variables? And what are the preconditions? Well, as we said, one of the preconditions would be that the sentence has to have a period in it. And then we probably would want to have a variable that counts each character as we go through the loop. So when it comes to setting up the bounds, we'll write the code that will actually take input from the user. We'll assign that input to a string variable str. Then we'll need a char variable to help us move towards the bounds. We'll call this variable ch, short for char. And we'll want to set that char equal to the first character in our string that was input from the user. So this is a precondition that primes the loop. Then the body of the loop will move us forward towards our bounds. We'll keep going through each time and assigning the next character in the string to our char until that char is a period. So here you can see the example for this code. First, we prompt the user to enter a string. And if we wanted to strictly adhere to one of our conditions, which is that that string must have a period in it, you probably would want to indicate that in your prompt as well. Then we initialize a variable count and assign it to 0. Next, we create a string variable, which is assigned the input from the user, from the keyboard. And then we initialize our char ch variable with the first character in that string. And that's called priming the loop. Then we use a while loop here, and you can see that our condition is we want to continue this loop as long as char does not compare to, is not equal to a period. Each time we go through the loop, we just increment our count variable. That will help us move towards our bounds, because what you'll see in the next statement there is that we're grabbing the character in the string based on count each time through the loop. So since count starts at 0, we'll get the first character, which will then be checked to see if it is a period or not. If it's not, we'll increment count. Then we'll assign char at 1, since count will be 1 at that point. We'll look at the second character in the string, assign that to char, then test to see if that's a period. If not, increment count. Now we're at 2 for count, so we're at the next char in the string, assigning it to the ch variable, checking to see if that's a period. on and on. So the count is actually allowing us to go one by one, character by character, through that string, evaluate it each time to see if it's a period or not. If it's not a period, increment count, and then check, or I should say, reassign to ch, our variable, the next character, check it, on and on until we reach the period. Once it's false, then we exit the while statement. And then we could even add a statement after the while loop there that would then identify how many characters were in the string before we encountered the period. Next, we're looking at the for loop. It's a counted loop, probably the easiest loop to comprehend. All the components are on a single line next to each other. Consists of three components: the initialization expression, the test expression, and then the update expression. Here's a graphic to represent that. You'll see we use the keyword for. Then in the parentheses, we have the initializer expression with a semicolon after that, followed by the Boolean test expression. That's followed by a semicolon, and then finally the update expression. So all of that's inside of a set of parentheses, and then we have a curly brace to represent the statement blocks that will occur as long as our Boolean test continues to evaluate to true. So here's a simple example of how the for loop works. We have our keyword for, and then we have our three components inside of the parentheses there. So we have the initializer, we have the Boolean test, and we have the update expression. So the first thing that happens is our integer I gets assigned the value of 0. Then I is checked to see if it's less than 3. If it is, which it is at this point, we'll go ahead and print high to the screen. Then we increment I, now it's the value of 1. Then test I, see if it's still less than 3, and it is. So again, we'll output to the screen the word high. Increment I, test I, still less than 3, print to the screen high. Now we increment I. Now this time I is equal to 3. It's no longer less than 3. So when we evaluate I here, we exit the for loop and go on to the next statement after that loop. Here's an example in code, taking input from the user, assigning that input to a string s. So we're just having them enter some text. We then initialize a counter variable. We just call it count and assign it to 0. Then we set up the for loop. We're initializing the I in the for loop as 0. The Boolean test is to check to see if I is less than the length of our string. So s is the variable that contains our string. We're applying to that the length method, which will count the number of characters in the string. And then we're just incrementing I each time through the loop. Now in this particular example, what we're going to do is actually count as we go through each of the characters in the string. We're going to count to see how many uppercase characters there are in that string. So we also have an if statement in here where we're checking to see if the character we're at this point in time, so first character, second character, as we go through the loop, we're checking each individual character. So whatever character it is in the string at that time, checking to see, is it uppercase? If it is, then we're going to increment our count variable by 1. If it isn't, we don't increment the count variable. But we still continue through the loop until we get to the end of the string, because the loop is going to run based on the number of characters in the string. Then for the final output, after the for loop has concluded, we'll have the text you have, and then concatenate to that our count variable's value at that point in time, and then concatenate to that uppercase chars. So you have X amount of uppercase chars in the string you typed in. So that initialization section has a few particularities about it that you should be aware of. It's encountered first. It's the first clause of the loop, and it's used to create and initialize a counter. It's semicolon separated, and it can have multiple initializations. They must be comma separated, and they must also be of the same type. So in the examples on the right there, you can see we're creating a single initializer, int I equals 0 in the first example. In the second example, we've got two initializers. We're getting an int I equal to 0 and an int j equal to 1. In the last example, that would be illegal because we're trying to initialize a double at the same time we're trying to initialize an integer. In the test expression, the Boolean test expression, it's found after the initialization section separated by a semicolon. It's before the update expression. It's just like an if statement test. We're doing a Boolean evaluation of the expression, so we can use any kind of relational operators in there. We can have a compound test using logical operators. In the second example, you can see we use the AND operator to check to see if I is less than 10 and if j is less than or equal to 7. But it cannot have multiple tests. So the last example you see is illegal. You can't have one Boolean test separated by a comma and then another Boolean test. So compound tests are okay, multiple tests are not. And then finally the update expression, it does appear last, again after the semicolon, after our Boolean test expression. And it's used to update our counter, so it moves our loop towards its bounds. And like the other components, it can have multiple update expressions. So in the second example there, you can see that we're incrementing I as well as j. And notice that j wasn't even part of the initialization expression in this case. So sometimes you may have it as part of the initialization expression, and other times you would have it initialized before the for loop begins. Up to this point, we've only seen the for loop increment, but you can decrement any of your loops, meaning you can count down as you're going through your loops. So all we'd have to do is just decrement whatever the counter variable is that we're using for that loop. And here's an example then of reversing a string using the countdown method. In this case, we're just asking the user to enter some text, assigning that text to a string s, and then in the for loop, again, we're using the length as our Boolean expression, the length of the string is our Boolean expression, that is the bounds. But this time you can see that we're going to be decrementing our increment counter. So increment counter here is going to be integer I, and it's going to be equal to string length minus 1, because you have to remember that strings are actually what we call arrays, and arrays begin at 0. So the first character in a string is always 0. So we just have to reduce the length by 1 so that we don't exceed the number of characters in our string, which would throw an error. So again, it's integer. Our initialization is integer I, which is assigned the value of string length minus 1. We're testing to see that I is greater than or equal to 0. And since I has the total number of characters in our string, say we have 10 characters in that string, then we're going to count down each time that we go through the loop here by using I minus minus, the decrement operator. Each time through the loop, we're just simply printing the character. So we're starting at the end, right, because we're starting with I equal to s dot length minus 1, so that's the last character in the string. So we print that character. We go back and decrement then the value of I, so now we're printing the second to last character, and then the third to last character, on and on through the loop until we have printed all the characters in the string to the screen until our I is at 0. You can also count by multiple steps, as you see in the examples to the right there. You can use plus equals and then some numeric value. So if you want to jump by 2s, you can do that. Jump by 3s, whatever number you want. And you can also do so exponentially by using the multiplies equals. And notice there, because we're doing it exponentially, you're multiplying I times I. In this example, we're taking some text from the user, and we're going to add up the value of each character in the string that they type in. So S is going to be the string value that's input from the keyboard by the user. Then we initialize an integer sum, make it set it to 0. In the for loop, we initialize I as 0. We're going to run it as long as we're less than the length of the string, and increment I each time through the loop. The only statement we have in the loop there is our sum variable then is being incremented by the value of the char that we are currently reading from the string. So notice what we're using here is a casting so that we can get the actual numeric value of that character. So the string, remember, is the set of characters that the user typed in. We're checking the first character in the string the first time we go through the loop. That gets converted, that character that's the first character in the string gets converted to its integer value and added to the sum variable. Then we go back through the loop, we get the next character, convert its numeric value to an integer, add it to the sum, and just on until we get to the end of the string. So we've checked each character, taken the value of each character, converted it to an integer, and added it to our sum variable each time through the loop. And then once we exit the loop, we just print the sum of the characters is, and then the value of sum, which would be the total of all characters in that string. You can omit expressions from the for. You just need to make sure that you have the placeholder for all three expressions. So notice in both examples here, the first example, we've initialized I equal to 2. We're going to run the loop as long as I is less than 1,000. And then within the loop body, hopefully you're going to increment I at some point, because otherwise this would be an infinite loop that would run forever. But notice there wasn't any increment value to the right of the Boolean expression. And then in the last example, that actually is a legal for loop. No initialization, no Boolean test, and no update to our initialized variable. So all the mechanics of that would have to be in the loop of the body, or again, you would have a loop that loops forever. To review our lecture, we took a look at repetition structures. We discussed the difference between loops and decisions. Then we showed you loop constructs, loop classifications and categories. We focused in on loop bounds and loop goals to make sure that you configure your loops correctly and that they exit properly, don't run forever. And then we took a look at the for loop, the syntax of the for loop, how the for loop worked, and gave you various examples of using the for loop. If you liked this video, please click the like button and leave us a comment down below. I also would appreciate it if you would subscribe to our YouTube channel. Also, click the notification bell so that you'll be notified when new videos are posted.